Hi class, so this week we're covering Chapter 7, Group Research Design. So the objectives for this week is to describe the difference between group research design and case level research design, suggest an appropriate group research design based on what the research question requires. We're going to understand group research design notation as the building blocks of research design. We will describe the strengths and weaknesses of the different types of group research designs. We're going to explain what is meant by internal validity and how threats to internal validity vary with the choice of group research design. And we're also going to explain what is meant by external validity and how threats to external validity vary with the choice of group research design that you choose. So here are some questions that you would have to be able to consider doing group design. So, experimental conditions. Does cognitive behavioral therapy work better than non-directive counseling? So clearly you're looking at two different interventions, right? So cognitive behavior therapy and non-directive counseling. So you're looking at whether either one of them are better. So another question could be whether 12 group sessions were as effective as a 16 session. How will change in eligibility for free lunch affect the number of people applying for the program? Will reduced caseloads improve the recidivism rate for families with child abuse? So usually with group designs, you either have two groups or you're looking at two different tests. For example, if you do pre-test and post-test. So in looking at whether reduced caseload improves recidivism rate for families with child abuse, you can look at those with a higher caseload versus those with a lower caseload and see the difference in the recidivism rate. And if you notice that it does decrease with, or it does improve with the reduced caseload, then you would be able to tell that there is a difference. All right, so here's your types of group designs. So starting at the bottom, this is where we would start. Your question one, first thing you need to ask yourself, is there random assignments to groups? So are you randomly assigning your participants to a specific group? So usually you have two groups. So when you ask yourself, is there random assignments to group? If your answer is no, then you go over here. And your next question is there more than one group or multiple observation points? So even if you're not randomly assigning them to groups, you would still ask yourself, is there more than one group or multiple observation points? So if you have more than one group, the answer is yes. You would have a quasi-experimental research design. If your answer is no, is there more than one group, you may still want to ask yourself, is there multiple observation points? Because even if you only have one group, you may have multiple observation points. So the answer would still be yes. So for example, if you only have one group, however, you are doing a longitudinal study where you would do a pre-test and maybe you give an intervention and then you do a post-test. So even if you're doing pre and post-test, that's multiple observation points, right? And if you're doing a longitudinal study where you're observing them longer than that, for let's say you do pre-test, post-test, and then 6 months later, and then a year later, that's multiple observation points. So whether you're observing them twice, like at pre-test and post-test, or you're observing them longer than that, the answer would be yes. And so your design would be quasi-experimental. However, if no, you don't have more than one group, and no, you don't have more than one observation point. So for example, if you are just surveying them once, what we call cross-sectional, you're just collecting data in one point in time, that means you only have one group and you're just surveying them once, the answer would be no, and you would go over here. And your research design would be pre-experimental. So going back down here to our original question, is there random assignment to groups? If your answer is yes, you're randomly assigning them to groups, which is your intervention and your control group. Then the answer is yes. You would go over here and your research design is experimental. Okay, so design notation. I'm not going to spend a lot of time doing this, but I at least wanted to introduce it to you. I can't remember it using this at all when I publish anything. So, but it's always good to know what it means because some people do use it. And if you're reading an article, you may not know what it means if you just see an X or an O or an R. So the X is the exposure to the independent variable. O is your observation or your measurement that you're using. O1 is your first observation of measurement. So the R stands for random assignment. So not matching. You're randomly assigning your participants to either intervention or control group. With the random assignments, all elements have an equal chance of selection for either being in the experimental or the control group. So whenever you randomly assign your participants to either group, all of them have an equal chance of being selected for either of those groups. With the pre-experimental design, we have cross-sectional. I know you've heard me mention that before. So your cross-sectional, also called a one-shot case study, basically this is how you would know. The notation would be just an O. It's one observation. You only observe them one point in time. You just survey them one point in time. So the cross-sectional is an exploratory or a descriptive study. So if you're doing either one of those studies, you can use a cross-sectional design. You're only going to have one measurement of one group. So the simplest research design. And as you're working on your project, your final project for this class, you'll have to select one of these designs as well. Another design in your pre-experimental designs is your one group post-test only. So again, here you only have one group, but you also have an intervention. So here's how you would write that. Okay, and if you, let's say you only saw the X and the O1. This basically is saying, looking at the X, right, that's the intervention, and then O1 is your observation 1. So clearly with this design, you provide them an intervention and then you give them a test after. So you provide them the intervention and then you provide them your survey, right? So one measurement following your independent variable, which is your intervention. For example, here's a research question. Okay, so in looking at this research question, has a minimum standard of achievement been met? Using the one group post-test design, you would give your intervention and then you would measure them after your intervention. So with the quasi-experimental designs, it provides comparison measures. With the pre-experimental designs, those are just one measurement. With the quasi-experimental, you have comparison. So you basically do at least two measurements. So you can have additional measures over time, or you can have additional groups without random assignment. So with the quasi-experimental design, even though you have two groups, you don't have random assignment, and that's why it's quasi-experimental. Okay, it's only experimental when you randomly assign them. With the quasi-experimental designs, you cannot rule out alternative explanations for change in a dependent variable. So basically, because you didn't randomly assign your participants, you cannot say that it was some other factor or there's some other explanation for the change that you observed. So with this design, you can have a one group pre-test, post-test design, okay? So the notation would be O for observation, and then you have the X for intervention, and then O for observation again. So with this design, you would do a pre-test, you would provide the intervention, and then you would do the post-test. You can also have a post-test only with non-equivalent groups. So here you have two groups, but you're also, with the first one, you only had one group, but you're observing them twice. Okay, so you measure them twice. With the second design, you have two groups, and if you notice, you're only observing them once. However, only one gets the intervention. So the first one X for the intervention, and then O for the observation, which is, in this case, a post-test. So the first group gets the intervention, and then they get a post-test. The second group does not get the intervention, but they get a post-test. So here you're comparing the two groups, and you're looking to see if there was a difference or if the intervention made a difference because one group got it and the other didn't. So then you have the pre-post test with comparison groups. So with this design, you still have two groups, but now you also have a pre-test and a post-test. So with the first group, you give them the pre-test, then you give them the intervention, and then you give them the post-test. With the second group, you give them the pre-test, there's no intervention, and then you also give them the post-test. Okay, then you have the multi-group post-test only. So if you can see, there's 3 different groups here, and each one of those groups are getting a different intervention, or at least a different level of that intervention. So it's labeled X1, X2, X3. So if they were getting the same intervention, it would have been X1 for all 3 groups. However, because the intervention is different, whether it's different levels or a completely different intervention each group is getting, they're labeled as X1, X2, and X3. However, if you notice for observation, they're all getting post-test, so they're only doing a post-test. However, they're all being observed just once, and they're all getting the same post-test, so it's only O1. So with the simple time series design, there are multiple measurements of the dependent variable before and after the introduction of the independent variable, which is your intervention. So if you look at the notation, you have multiple measurements. So O1 for the first measurement, O2, O3, O4. So you can see there's 4 different measurements. And then you introduce the intervention, and then you keep following up with more measurements. So you just keep going from where you stopped off, 5, 6, 7, 8. So with the time series design, you're looking at the multiple measurements before and after the intervention. There's also the multiple time series design. So basically what you do is just add another group, right? So you have 2 groups, you have your 4 measurements, then you do the intervention and 4 measurements after. And then with the second group, you have your 4 measurements, there's no intervention, and then you have your 4 measurements after, just like with the other group. So basically one is getting the intervention and the other group is not. So with the uninterrupted time series design, these are observational research without independent variables. So here you're just observing them. There's no independent variable, there's no intervention. You're just observing them. So with the experimental design, this is a control method of observation where one or more independent variables is changed in order to assess the causal effect on one or more dependent variables. So the first design under the experimental design is the classic experiment. With the classic experiment, you have 2 groups, the experimental and the control. So here we're introduced 2 letters, the E and the C. And E stands for experimental, C is for the control group, R is for random assignment, and you can see both groups are randomly assigned. So with group 1, you have observation 1, the intervention, and then observation 2. So with the control group, you do the same thing. The only difference is they do not get the intervention. Another design is the post-test only design. So you have, again, 2 groups. They are for the random assignment. One gets the intervention, the other does not. And basically, they're only getting a post-test. Okay, so one group gets the intervention and the post-test. The other group just gets the post-test. So with this design, random assignment assumes equality at pretest. So with this design, because participants were randomly assigned to groups, it basically assumes that each group are going to be equal because they were randomly assigned. And so therefore eliminates the need to have a pretest. This is usually used when the testing or the instrument is an issue. So for example, if someone has a pretest and then they do a post-test, sometimes you can say that it's a possibility that they were tested before, and so they remembered the answers from the previous test, because most of the times pre-test and post-test are the same test. You're pre-tested, you get the intervention, and then you get a post-test. And so even with the group where they didn't get the intervention, if they did get the pre-test before, they've seen the test before, and so it's a possibility that that may also contribute to the results. And so with random assignment, it eliminates the need to have a pre-test, because it assumes that since they were randomly assigned, both groups are equal, and so you don't have to do a pre-test. The final design is the Solomon 4 group design. This is the most rigorous design, okay? As you can see, there's 4 groups. And this design is used to test the effects of pre-testing. So with the Solomon 4 group design, it combines the classic experiment and the post-test only control group design. So this design combines the 2 other designs in the experimental design. So that's why it's the most rigorous. It's the strongest design. So basically what it's doing is comparing the groups. So there's 4 groups. The first one, observation 1, then they get the intervention, and second observation, right? Pre-test, post-test. With the second group, they also get pre-test, they get no intervention, and then they get post-test. With the third group, they do not get a pre-test, they get the intervention, and they do get a post-test. And then with the last group, again, there's no pre-test, there's no intervention, but there is a post-test. And so there's 4 different ways at looking at the results, right? So comparing the second group with the fourth group helps the researcher to estimate the amount of change, if any, that is attributed to taking a pretest. For example, in a study of attitudes about HIV/AIDS, the independent variable is an education program. 4 groups are used. The members are assigned randomly to all 4 conditions. So the first group is given a pretest about their attitudes, then they're given the educational program, which is the intervention, and then they get a post-test. The second group is given a pretest and a post-test, but they are not given the educational program, so they don't get the intervention. The third group is given the educational program, which is the intervention, and they're also given a post-test, but no pretest. The fourth group is also only given the post-test. So the fourth group gets the post-test, they don't get a pretest, they don't get the educational program. So if group 1's post-test scores differ from the third group's scores, then the pretest can be assumed to account for the difference, since both of them got the educational program. Both of them got the intervention. And if group 1 and 3 scores are similar, but they're higher than groups 2 and 4, then the independent variable, which is the educational program, is assumed to have accounted for the difference. So if you're looking at group 1 and group 3, group 1 has a pretest and group 3 doesn't have a pretest. So if the post-test for group 1 is different from the post-test for group 3, then we can assume that the pretest here did account for some of the differences, right? Because group 3 doesn't have a pretest. And since they both got intervention, the only difference would have been the pretest. And then also, if groups 1 and groups 3, if their scores are similar, but if these 2 scores, group 1 and group 3, if they're similar but they're higher than groups 2 and 4, then we can say that the intervention made the difference, because both of these do not have an intervention. Okay? All right, so hopefully that made sense. So there are some limitations of experimental design. The high need for control limits generalization to real life, so it definitely decreased external validity. The high level of attrition may also compromise the group equivalent. So they have a high level of attrition, meaning that people do not complete the study or they drop out at some point. The threat to internal validity makes conclusions suspect. So there's threats to internal validity. So let's talk about the threats to internal validity. So internal validity is the amount of confidence we have that changes in your dependent variable are the result of the independent variable and not some other factor. Factors that jeopardizes the confidence are known as what we call the internal validity. Perfect internal validity in a research study is rarely assumed to exist. So we don't have perfect internal validity. You're always going to have some threats to your internal validity when doing a research study. Here are the 9 most common threats to internal validity. History effects are basically extraneous events, events taking place between pre-test and post-test that may have an influence on the results. So whenever you have a pre-test and a post-test, you can definitely expect to have the history threat, because any extraneous events that happen between the time you gave them a pre-test and the time you gave them a post-test can have an effect on the results. For example, recent mass shootings targeted at law enforcement officers could influence the outcomes of a study that measures anxiety among spouses of law enforcement officers. So let's say you were doing a study on anxiety among spouses of law enforcement officers, right? You gave them a pretest. But before you gave them a post-test, there was a mass shooting targeting law enforcement officers. That will definitely affect the results at post-test, right? Because at pre-test, they may not have had their anxiety levels, even though they have anxiety because their spouses are law enforcement. However, because of the mass shooting, I'm pretty sure that's going to make their anxiety go up higher, right? So it's a possibility that it can be contributed to history because of what happened. And this explains the history threat. With maturation, it is a threat that occurs when an observed effect is due to a respondent growing older, wiser, stronger, or more experienced between pre-test and post-test. Again, this is another threat that you can expect whenever you have a pre and post-test. Just like, for example, a cut finger heals with time, right? So as time passes by, people get more wise, they get stronger, they get more experience, and this happens with or without the independent variable. And so looking at pre-test and post-test, you can expect that maturation could occur. If you're doing a cross-sectional study where it's just one point in time, then you wouldn't have the maturation threat. Then you have the testing threat. So with the testing effects, this basically involves the danger that observed effects are due not to the independent variable, but to the fact that performance on a test is influenced by taking a pretest, right? So testing effects may be due to the number of times particular responses are measured and the chance that familiarity with the test enhances participants' performance. Or in some cases, what we are measuring may be the ability of participants to remember the answers they perceive as correct. So with pretest or with the testing, this definitely happens when you have a pretest and post-test again, because whenever you give a pretest, then it's a possibility that participants will remember those test questions and will do better because they've seen the questions before. Like with the SAT test, the results get better the second time around that you take it, right? So it's the same thing with pretest and post-test. Post-test is basically taking the pretest a second time. It's like you're learning to take a test. And it's like you're also learning because of the test. Because, for example, reading about parenting techniques after a parenting test. So if participants had a pre-test about parenting techniques, then they may go and read about parenting techniques after that pre-test. And so whenever they get that post-test, they would have had more knowledge about parenting techniques because they went out and looked up the information. Instrumentation refers to unintended changes in the way that the dependent variable is measured over time. Instrumentation can arise from problems with the measuring instrument and the observer. For example, an observer may get bored or they may change his or her rating style during the study. And so that can affect the results as well. So with instrumentation, you're definitely going to have a threat if the pre and post tests are different. Most of the times they're the same, but sometimes you can change them. However, if they're different, then you have the threat of instrumentation. Does taking the test change responses? And whether the raters get bored or better at the rating with time. And so each one of those things can have an effect on the instrumentation and therefore causes the threat instrumentation. Next, we have statistical regression. This one, we can't do much with this. It can occur whenever a group is chosen because they are extreme. And so in such cases, the tendency is for both very high scores and very low scores to move towards the mean, regardless of the treatment that they're getting. So for example, the most anxious members of a group are likely to be somewhat less anxious at the next measurement. So basically, if you have the most anxious members of a group, then they're likely to be less anxious the next time you measure them because they were the most anxious. So they had nowhere else to go other than to be improved, right? Then we have the selection bias, and this exists when the groups are not comparable before the study. So in such cases, the change observed in the dependent variable could be due to pre-treatment differences between the groups rather than to the independent variable. So basically, selection bias happens when the groups were not comparable at the beginning. So whenever you don't have random assignment, you will have selection bias because your groups may not be comparable, they may not be similar. And because they were not randomly assigned, we cannot assume that they were equal at all. Because, for example, all your troublemakers could be in the control group. And so it would definitely make a difference when all the troublemakers are in the control group and then all the good ones are in the experimental group. Then clearly the experimental group, they're getting the treatment and they weren't the ones needing the treatment. So therefore, that will definitely have an effect on the results. So with experimental mortality, this basically happens when people drop out of the study. And so you have to think about whether the dropouts are different than those who do stay in the study, and how many dropped out and who's left, and how are the ones that's left different from the ones that dropped out. Treatment contamination can happen when participants in one group, so for example, participants in the control group, learn about treatment being offered to members of another group, so members of the intervention group. Or also when program personnel provide some compensatory benefits to those who form the control group. So in some cases, treatment contamination is so serious that they have to cancel the experiment. In other cases, treatment contamination occurs naturally. For example, when youth in the experimental group discuss on the playground what they learned in an HIV or AIDS educational program with youth that are not in the program but are also in the control group. So they may know information now that the other group was getting or learning from the intervention that could also change the study results. For example, when youth in the intervention group talks about the program to the other group that are in the control group, they are learning about the program itself. And so obviously they're going to show improvement because they also learned about the intervention. So kids teaching each other. It can also be a case where therapists learns techniques from each other. Then we have the resentful contamination. So with this one, it is a reaction to being part of the control group. So sometimes membership in the control group is believed to be negative, and this can cause resentment, anger, and demoralization that can inflate the difference among the two groups. For example, youth may see going to a climbing wall activity as a privilege, and those not selected to participate may be resentful. Thus, this can also affect their scores on a measure of commitment to the school. So basically here, the control group resents being in the control condition because they're not getting the intervention. And this can cause greater differences between the groups. So with the treatment contamination, basically the intervention group teaches the control group about the intervention, and so they learn about it anyway. With the resentment, the control group is upset or resents being in the control group because they know they're not getting something, they're not getting the intervention, and this can cause differences between the groups. So with external validity, it is the degree that research findings can be generalized to other cases not studied as well as to the population in general. So external validity is basically what allows us to generalize our study results. So it's the extent to which studies are reflective of real life, because experiments are planned and life isn't. Experiments are simple, life isn't. So when it comes to external validity, it's basically those that we can show that our study is reflective of what it would be in real life. Generalization must take certain things into account. We have to look at the age, race, sex, class, education, reading level, different things like that in terms of who are we generalizing this to. Organizational setting, the location, culture, to whom do these results apply? Okay, and that's how we would be able to generalize. We also have the reactivity or the Hawthorne effect. So whenever people know that they're a part of an experiment, they're in a research study, then they may change their typical behavior. So they know that they're being observed, so they may behave differently. With the researcher bias, it's basically that the researcher sees what they want to see. And so researchers evaluate experimental and control groups differently. The one way to solve this problem is to use double-blind method when possible. A double-blind method is when, so neither the researcher nor the participant know whether the participant is in a control group or the experimental group. We also have multiple treatment interference, and so this happens when the effects of two or more treatments cannot be separated. Researchers have no control over what other resources people can access voluntarily or to whom they may talk to. And so, for example, in our research on the abstinence-only program in middle schools, it was difficult to find children who had not been subject to multiple forms of sex education in the schools before entering the program. So you as a researcher have no control of who's talking to who or who's reading what or where they're getting information from. So for example, those in treatment may also be talking to a minister or coach, or a parent education group may also be reading about parenting skills. And so the researcher has no control over what the participants are doing and where they're getting information from. So that becomes multiple treatment interference, because now it's difficult to tell whether the intervention is working or whether the participants are improving or doing better because of outside information or from talking to other people or from reading about the topic and things like that. Okay, so this brings us to the end of chapter 7. So in chapter 7, we talked about the different research designs. At this stage, I would go ahead as a group and try to decide what my research design is going to be. We talked about all the designs that you can use, and so it's a good time to go ahead and select that design and start writing that part of your paper, at least the draft of it, so that you don't fall behind. Every time we cover a certain part of your paper, it's always a good idea to go ahead and start working on that area so that you can have enough time to finish your paper. All right, so I will see you guys next week for our live chat, and where I'll talk a little bit more or answer any questions that you guys may have on the different designs that we talked about today. See you next week.